Okay, in this lecture, we're going to just go through a quick Excel tutorial on how to basically break your data up into quartiles, percentiles, deciles, so on and so forth. How to use those formulas that are already built into Excel to be able to do what it is that you're trying to do. So I've got some data here, and the data is from the Use This Data tab, and so I just copied and I pasted just a few of those into this worksheet right here. So I included ideal outdoor temperature, expected dinner cost, time willing to travel, and amount spent on books. And so I'm just going to increase, let's see, insert, and insert. Okay, so what we're going to do is we are going to basically find the position and the values for the different, basically the different points in this data set. So we have expected dinner cost, we have time willing to travel, like I said, and let's see here, we're going to insert one more here. Insert, there we go. So I already did the first one, and I'm going to show you. So it says sort smallest to largest. So we've got ideal outdoor temperature for eating, and the very first step is we need to sort from the smallest to the largest. And you'll notice that there are a total of 51 observations here. And with the 51 observations, each one of them has a position. So there are a total of 51 positions amidst this data set. And so if I put them in order from least to greatest, they will be in 51 positions. So if I said, what is the data point, or what is the value of the data, or the value of the observation in the 43rd position, I would come down here and I would say, okay, it is 75. 75 is the value that is in the 43rd position. If I were to say, what is the value of the data in the 19th position, then it would be 70. Okay, so we sorted it from smallest to largest. The next thing that we have to do is we have to put the labels in and say, okay, we're going to find the appropriate positions and values that are associated with certain terms or certain concepts. And so particularly we're looking at Q1, the median, and Q3. Now what's really important about this is that these values, these positions, what they are is they are positions that split the data set more or less into 4 even parts. So it's not so much that you're looking at it to be inclusive or exclusive. You're not saying, okay, Q1 is this value, so it's this to this inclusive of Q1, or it's this to this exclusive of Q1. More importantly, it's supposed to divide the data set into 4 even parts. And as you notice right here, you've got Q1, which we're about to get to, but Q1 is, just happens to be the value associated with Q1 is 70. Now, if I were to say 70 inclusive, that would include all of these, and that would include almost the entirety of the of this entire second quartile, and that's not the point. What we're supposed to say is the value that delineates between Q1 and Q3, or sorry, Q1 and Q2 is going to be 70. And so what we're really looking at is, okay, where is it that there's 25% of the data, and then the next 25% of the data, and then the next 25% of the data, and then the next 25% of the data, because that is what's supposed to happen. You're supposed to be breaking this data up into 4 even parts. So in order to find the position of the 4 even parts, we're going to use this formula right here. And the formula is Q1 equals 1/4, in other words, the first quartile, 1/4, multiplied by, and more specifically, I'm going to put n plus 1. Okay? Make sure that we get the good order of operations here. And And so the reason why we have n plus 1 is, like I said before, is it's not supposed to fall necessarily on a particular value. It's supposed to break those values up. It's supposed to find that delineating point. And when you do n plus 1, what that does is it puts in essentially... it accounts for the percentiles. It puts in just a little bit of a gap between all of the different values, so that way you can try to find yourself in the middle of a value instead of finding yourself right on top of a value. And so we've got 1/4 multiplied by n plus 1, which n is 51. There's 51 observations. So n plus 1, that's 52. So we have 1/4 equals 1 divided by 4, and then multiplied by 52. And that's going to give us 13. 13 is not the value, but rather it's the position. So we go down to the 13th position, and what we're saying is that this position is the position that divides the first from the second quartile. So this is the dividing point. So anything above here is in the first quartile, anything below it is in the second quartile. And like I said, it's really not necessarily supposed to fall on a value, but what's more important than saying, oh, it's that this particular value is in Q1 or this particular value is in Q2, what's more important is that you're just dividing it into 4 even parts. And so there's really an argument that can be made for putting it into Q1 or putting it into Q2. The bigger point is that this is the dividing point. So so I'm okay with you putting this particular value in Q1 or Q2. So I would say that this is Q2, and then I would put this all as Q3, and really just use your common sense and look at where the actual values are. And so that way you can be a little bit more intentional with what you're doing. So next we have the median, which we're once again going to find the location of the median. These formulas right here, they give you the location. And so the median is 1/2 multiplied by n plus 1. So 1/2 multiplied by 52 gives you 26. So 26 is the position of the median, which is 71. So 71 is the dividing point, or 26 is the dividing position, and 71 is the value associated with that. So anything above that is in the first half of the data. Anything below it is in the second half of the data. And then once again, use your common sense as to where you're going to put 71 itself. So I would put it with its siblings there. Next, Q3 equals 3/4 multiplied by n plus 1. And so we have 3/4 multiplied by 52 equals 39. So 39 is right there. That's the position. This is the value associated with the position. And then we have the entirety of Q4 is right down here. Once again, when we get Q3, the value or position of Q3, what we're talking about is the delineating point. So we found all of the positions right here. Then we labeled them, and then after that we found the values associated with them. The next thing that we're going to do is we're going to find the interquartile range. The interquartile range is when you take the value of Q3 and subtract the value of Q1. That's the range of the between the range of the two quartiles in the middle. So that's the interquartile range. So we've got Q3, which is 75, the value is 75, and then Q1, which the value is 70. And so we do 75 minus 70, which gives you 5. So 5 is the value of the interquartile range. So I put interquartile range right there, which is 5. And when I did that, now I have the ability to calculate outliers. Which outliers is really important because you want to know, okay, is our data, does it have things that are really skewing it, that are really throwing everything off? And the answer is, well, let's see. So I'm going to use this formula, which the formula is Q1, or the value of Q1, which is 70. So equals 70. And then I'm going to say minus 1.5 multiplied by 5, which is the interquartile range, and that gives us 62.5. So anything below 62.5 is going to be an outlier. So this is a little bit more important, because this right here is what I would refer to as the outlier limit, or the lower outlier limit. So anything that is 62.5 or greater is not going to be an outlier. Anything that is less than 62.5 is going to be an outlier. So that one is important to be inclusive or exclusive. So if you're saying what is an outlier, it would be exclusive of 62.5. If you were to say what is not an outlier, it would be inclusive of 62.5. So this is the lower limit, so we're going to put this right here. And then the upper outlier limit would be Q3, or the value of Q3, which is going to be 75, equals 75 multiplied by 5 times, 75 plus 5 multiplied by 1.5. So we've got 82.5 is the upper outlier limit, 62.5 is the lower outlier limit. And so anything greater than 82.5 is an outlier, anything less than 62.5 is an outlier. Okay, so now we're done with this, but I want to show you one more thing. I'm going to highlight this, and I'm going to make a box and whisker plot. Insert box and whisker. And you'll notice you've got all those outliers, and you're like, oh, I only see a few outliers down at the bottom, but I see 5 outliers right there, and I only see 4 outliers right there. Well, the reason why is because 55, the dot on 55 is there twice. And so if we were to click on this and format, design, add chart element, data labels to the left, you're going to see the 55, you're going to see the 59, 60, and 15, and then you've got an outlier on the other side, which is 89. And so you've got all these outliers, and everything looks to be correct. So, that box plot is very reflective of breaking things up into quartiles and being able to understand and interpret that. So next down here, I want to do things a little bit differently. We've got this data right here, which is expected dinner cost, and I'm going to sort it. Remember, very first thing, we sort it from smallest to largest. Sort smallest to largest, and continue with current selection. Press OK. And I deleted one entry just because, and you'll see why in just a minute. And I want to do things a little bit differently too. Instead of Q1 being 1 over 4, I'm going to do 25 over 100. And the reason why is because when you calculate a percentile, percentiles equal the percentile that you're looking for over 100, multiplied by n plus 1. So the percentile that we're looking for is the 25th percentile. The 25th percentile is the exact same thing as quartile 1. And so this particular data set, like I said, I deleted one entry. So it's got only 50. So what we're going to do is equals 25 divided by 100 multiplied by 50 plus 1. And that's going to give us 12.75. Oh, whoops, I forgot to do something. What did I forget to do? I forgot to put the actual positions in here. So these are the positions. So every one of these has a position. And right here we said, okay, 12.75 is the 12.75 is the delineating point between the two quartiles, but you don't see a 12.75. So what we're going to do is we're actually going to put insert, shift cells down, and we're going to put 12.75 right here. So 12.75, what it's actually going to be is 0.75 of the difference between this value and this value. So in this case, this value is 15 and this value is 15. And so what is 0.75 of the difference? Well, it's actually the lower position plus 0.75 of the difference. Well, there is no difference between the two of them, so the actual value is 15. So we're going to highlight this in yellow, and we're going to say this right here is the delineating point for Q1, and the value is 15. So let's do the same thing for the median equals 50 divided by 100. And we're going to multiply that by 50 plus 1. And that's going to give us 25.5. So we're going to go down and find the 25th. Okay, oh, we were right there. The 25th and the 26th. And so we're going to insert this right here. Let's see, insert. Shift cells down, and we're going to make 25.5. And the value is, once again, just because this is 20 and this is 20, this value is also going to be 20. Okay, but theoretically, if this was 21, then this would be 20.5. Because it would be 0.5 multiplied by the difference between this and this. So the difference between the two of them is 1. So it would be 0.5 multiplied by the difference between the two of these. So 0.5, the remainder, added to the lower one. So if there was a difference. So this right here is the median. And then we're going to put the value of 20. And then last but not least equals 75 divided by 100. And then we're going to multiply that by 50 plus 1, which gives us the position of 38.25. So we're going to go down to 38.25. Wow, this data set is really easy because literally every single time we land right in between right in the middle of a group. So 38.25, and we're going to put 25. Highlight this. Put Q3 and put the value of 25. Once again, you can find the interquartile range, which is 25 minus 15, which is going to be 10. Okay, and so the outlier is going to be in this particular situation 1.5 multiplied by 10 is going to be 15. So this is going to be 0. So anything below 0 would be an outlier. So there's no outliers here. And then 25 plus 15. What is 25 plus 15? That's going to be 40. So also there's no value that's above 40. So there's no outliers. So we've got Q1. We've got the median. We've got Q3. There's no outliers here. If there was a difference between these, we would have a slightly different delineating point. But for all intents and purposes, we've got Q3, that's Q4, this is Q3, this is Q2, and then this is Q1. And then all the yellow marks are the delineating points. Hopefully that's beneficial to see how the percentiles work. Let me do one more just for kicks and giggles. I want to find the value at the 80th percentile. So if I were to do that, I would put equals 80 over 100, and then I would put multiplied by 50 plus 1. So it'd be 40.8. I want to get one that's right there. I want to get that one. Let's see here. I want the 44th. So let's do the, let's see, what would the 85th percentile? Almost there. I want the 86th. Will that get me there? Nope. 88th percentile. There we go. So if I want the 88th percentile, this is what we're going to do. I want the 88th percentile. I'm going to insert for the 88th percentile. And the position is going to be 44.88. And then I'm going to look at the difference between the two of these, which is going to be 2. And I'm going to do 25 plus 25, equals 25 plus 2 multiplied by 0.88, and that gives you 26.76. So 26.76 is the delineating point for the 88th percentile, or that's the delineating value for the 88th percentile. So I just wanted to show you how to do that once where there was actually a difference between the two. So that's all I got for this one. It really shows you how things go in position with labels and values, percentiles, quartiles. You can do the same thing with deciles. And if you want more practice, you can keep on working on the rest of these as well. Or if they're required for your homework, then do it. So yeah.